The nice thing about polynomial long division is no matter how ugly this divisor gets, polynomial long division is basically always the same. Whereas if you were using synthetic division to accomplish this arithmetic right here and get the quotient and remainder, synthetic division would now require some different techniques. You could still do it, but there would be a little more going on than usual. So without any extra rules, I'm going to do the long division method here. First thing we do is divide negative 12x to the fourth. My pen has gotten really big here. Let's make this smaller. First thing we're going to do is divide negative 12x to the fourth by 4x squared. And what do we get? Let's see, little math here says this is going to be negative 3. Negative 12 divided by 4 is negative 3. And x fourth over x squared is just x squared. So I have negative 3x squared. And now I'm going to multiply that by this entire divisor. So we'll get negative 12x to the fourth again. We get negative 3x to the third. And we get positive 6x squared. It really does pay for you to take your time and go through these steps slowly, because one mistake at the top is obviously going to go, well, the whole problem is going to go sideways by the time you get to the bottom. So make sure you get your arithmetic right here. Now I'm going to subtract this whole row from the one above it, which means flipping the signs and adding them up. This one becomes 0. 5 minus negative 3 is positive 8. So this is 8x cubed. And notice I have a 0x squared in here. That's just a placeholder for your convenience. If you didn't see any x squares, like let's say it looked like that and there was just a blank there, you would want to write in your own 0x squared just to help you keep track of this. 0 minus 6 is going to be negative 6x squared. And then this guy I'm just going to carry down, negative 7x. Okay. Now we take this new row and I divide it by 4x squared again, right? 8x cubed over 4x squared. So that gives me, let's see, 2x, I think. And now I multiply 2x times that whole divisor. So 2x times 4x squared is going to be 8x cubed. 2x times x gives me, almost messed that up, 2x squared. And 2x times negative 2 is negative 4x. Now we're subtracting this whole bottom row from the one above it. Obviously on the left you always get a 0 if you did things right. Now we've got a negative 8x squared. And then negative 7 minus negative 4. Remember, there's a sign flip going on there. So that's like negative 7 plus 4. That becomes negative 3x. I carry down the 9 at the end. And now I have this. So one last time, I think, and we should be done. I'm dividing negative 8x squared by 4x squared. And that gives me negative 2. Negative 2 now multiplies against that whole divisor over there. So we get, let's see, negative 2 times 4 is negative 8x squared. Negative 2 times x is negative 2x. And negative 2 times negative 2 is positive 4. I'm going to subtract this whole row from the one directly above it, giving me 0. Negative 3 minus negative 2 is another one of those sign flips. So I get negative 1x. And 9 minus 4 is 5. So look at this. This is interesting. My remainder is not a number that we're used to, like 3 or 0 or 5. It's a polynomial. This is a polynomial remainder of negative x plus 5. That's what you put in here. And likewise down here, negative x plus 5 is the remainder. And we know we're stopping there because if you tried, look at this, if you tried dividing negative x by 4x squared, that's not going to work out. You have too many x's on bottom. It's not going to divide nicely. So that's why I know I'm done at this point. The quotient, again, is whatever is up top. That's what goes in here for your quotient. So that's negative 3x squared plus 2x minus 2. Now, is this a remainder? I mean, is this a factor or is it not? Is 4x squared plus x minus 2 a factor? Well, the remainder is not 0. So this is not a factor. If the remainder were 0, it would be a factor. But there's a whole lot more not factors out there than there are factors.